Hi guys, can you hear me okay? Sweet. I'm just waiting for the screen to come up. There we go. So hi guys, my name's Cameron Clark. I'm from New Zealand. I'll try and talk slowly. I don't speak German, so I'll just cruise along. If I'm going too fast, just tell me to slow down. But I'm here today to talk about the fact that automation and the various levels of automation to autonomy, it's a journey. And for us at Trimble, how we get to the journey of autonomy is important, and it's critical for how we get there. It's not going to happen overnight. I've always got this joke, I say autonomy is a journey, not the rock band. So a little bit about myself. I've been with Trimble Navigation now, next week actually, will be 22 years. And in that time, I've been in the construction industry, and I've seen all the changes along the way. And if anyone gets worried about autonomy and automation, like, we're already on this journey, when we've been on it for 20 plus years. Some people might not know it, but we are. And I'll talk about a few things today, so hopefully you guys find it interesting, and I'll try and remember to keep going slow. But when you look at construction, the construction industry has been continuously evolving. Machines are getting faster and bigger, and just look at from the old horse and cart days to what we've got today with the heavy machinery and all the operator comforts that we've got. So not only just the machines, but the machine control itself has been on a journey. And right through within Trimble with Bob Studebaker back in the late 60s, early 70s, when lasers were first introduced to motor graders. What comes after lasers and graders? Automation. So back in the 70s, we were automatically controlling a blade of a grader. So grade control's been around a long time. And over that, things that got better, faster, cheaper, easier to use as well. And a long time ago, things were very hard and complex, but things aren't like that anymore, and people understand and they trust grade control. So I just wanted to show you that grade control has been going a long time, and grade control is the start of autonomy. It's automation, and automation at different levels is how you get to autonomy. And that's what we're going to talk about today. So machine control, pretty much any machine that you want, you can put a grade control system on it today. All the main machines, excavators, dozers, graders, scrapers, you name it, if there's a will, there's a way. Dealers can make it happen. And you can also buy machines out of the factory with grade control. And grade control is critical because you can talk to OEMs and they can spend millions of dollars over years of time, and they're looking for 2 or 3% productivity gains. You can put grade control on a machine, and automatically you can get 30% productivity gains. So there's lots of studies out there. One thing that we like to do is compare lesser skilled operators with advanced operators. And when you're leveraging automatics, it's so easy because you can just turn a button and we can help you. And we can see that we can definitely help new operators, but we can also help experienced operators. And we've got some great examples where experienced operators are getting 41% faster and 75% more accurate. And we might not be able to make a lesser skilled operator as good as an experienced operator, but we can close that gap a lot. And we've seen examples of someone that's never really run an excavator before can get 28% faster. And the kicker here, 100% more accurate. And think about when you're doing excavation and stuff, and if you're accurate the first time, you can save money real fast, because if, say, you're trenching and you dig too deep, what are you doing with that material? Sometimes you've got to pay for it to get transported off-site. Then you come back in to put the pipe and you need the bedding. What happens? You need to actually put expensive material into the trench because you've taken too much stuff out. So yeah, a lot of cost savings, a lot of productivity gains, less fuel, sustainability. Sustainability is a key thing at the moment. And what we've got, so we know there's technology, there's a new workforce coming through that isn't afraid of technology. But we've also got, on the other hand, experienced people that are actually leaving the industry. They're retiring. So in Trimble, we call it the construction dilemma. Now, the problem, a lot of the systems that you can buy today, yes, you can automate it. You can click autos, and we can drive the blade to design. That's great if you actually know what to do as an operator. Like, where do I start to actually push the material? And with automatics on a dozer, for example, you could actually do the wrong thing faster before someone catches you. And the foreman goes, whoa, stop doing that. Now you're having to move the material twice. So a lot of the systems today still requires the intelligence of the person running the machine. But when you think about what we need to do for autonomy, we actually have to tell a machine what to do. And for Trimble, like I said right at the start, it's the journey to autonomy is important. And for the journey to autonomy, for us, and I think the last presenter also called it out. He said he didn't think that there was autonomous machines are going to come up tomorrow and you're going to see everything autonomy. You're not. It's the journey how we get there. And for Trimble, part of the journey is operator assistance. How can I help people run the job today? And then with that, not only do we as Trimble and other manufacturers learn, but you're also getting trust. And a contractor needs to be able to trust the system. And if they don't trust it, they're not going to trust it if they're always overriding something. And no one's going to buy the technology if it does it inefficiently. You're going to put an expert operator in there if you can find it. So for us, we want to help the lesser skilled operators. We want to prove that we can help the experienced operators. And then, as you can trust it and we can add more and more assistance, when there's no one in the machine, you're knowing it's doing what you want it to do. So with the construction dilemma, again, most of the systems today you can buy, you can put it in automatics, but you've got to still know what to do. And it's harder and harder to find the operators that are experienced. At the same time, population's growing, infrastructure needs are ever increasing. Old infrastructure needs to be maintained because the aging infrastructure needs to, you always see things like water mains bursting here and there. Things are getting old, so we've got to maintain it. The experienced operators are retiring. So you've got the start of a dilemma, right, of extra demand. People that know what to do are leaving. At the same time, safety, higher safety regulations, sustainability. Everyone talks about sustainability. You see it everywhere. So you've got all these things that are counteracting what you want to be able to do. But the good news is the new workforce comes through. They know technology. They understand it. They trust it. And we also know that contractors understand and they see the benefits of technology. In a lot of cases, construction companies are having to adopt technology just to even stay in the game. Because if you're bidding for something and you're bidding against a company that's leveraging technology that can do it faster, needs minimum material, then the costs are different. So people are having to adopt it just to stay relevant. But the good news, like I said before, within Trimble, we feel that we can solve this dilemma on our path to autonomy. The journey, not the rock band. So when you look at autonomous machines, firstly, you're going to know that construction is different than automotive, right? Automotive, you can get in a car, you can tell the system that you're going to the airport. It's like a single-man sport. Construction is like a team event. Everything's working around, and guess what in construction happens? You're moving the material, you're changing the environment. So it's dynamic as well. You can do a job today in one place, the same thing at another site, and it's going to be different. The materials change. There's rock. There's different weather conditions. It's completely different. So that's another reason why it's a journey, and everyone's got to understand how to be dynamic and make sure that you can use it and you're doing it like a real expert would. So, but we can still leverage and take what's been out there, but we need to adapt it and make sure it's going to be fit for purpose for construction. And with that, there's a lot of things, or what we call the role models for construction, is in ag. Autopilot. There's been systems that we've been able to steer planes as far as I can remember. There's a bunch of stuffs out there within steering and automotive stuff with ag. Actually, on that note, like within Trimble, a lot of our construction products that we've got today, we're actually leveraging that work that we've done in ag, and we're applying it in construction. So we can automate a dozer and steer it. We can steer a compactor. And compactors are very hard to actually steer because they articulate. And you're doing the same mundane task every day. And in order to make sure you don't miss anything, people are actually getting wider overlaps. So if you can automate steering on a compactor, we're leveraging the same stuff as we've done in ag. You can reduce those overlaps, and you can make that much more better environment for the operator. So ag is a big role model for construction. Mining and transportation is another one. Everyone knows there's been autonomy in mining for a long time. Caterpillar, right up there. Mining is different than construction though. A mine lasts for a long time in a controlled environment where you can control access. But all you think about though, what's happening in mining, you can take parts of it, but it's not the same. So you can't just turn the switch and take what you've done in mining to fit for construction. But there's a lot of learnings and a lot of things that we can reuse within mining and ag. Then you've got a lot of examples. Everyone knows Tesla sort of reset the bar and expectations. But then there's also lots of examples out there where you've got leader-follower type activities, where on the left-hand side, you've got a manned machine, and then you've got a safety vehicle coming in behind. If someone hits that, it's not very safe. So add safety, get the person out of it. It just has to follow that machine, that mower. Spreading removal of snow on airports. A manned machine, and then in this case, you've got three machines following in unison behind. So it's not full autonomy. Well, part of it is, but there's still a person in it. And it's all about the journey and the progression. So you step back and think, so what's really motivating? What's driving autonomy? There's certain tasks that are fit for automation and autonomy. Example, the compactor. Mundane job in a controlled environment where you're just going up and back doing spreading. If I was a contractor in a position where I could get the machine to do that, good. I'll go and do something else that's more useful for what I want to spend my time on. Think about an autonomous excavator. Excavators are very dynamic and they do a lot of things. You're not going to just have an autonomous excavator that can do everything, but you might have an autonomous excavator that can do a certain few tasks very well, and maybe I want to have a break or I want to go and do something else. I'll set that excavator off and do a task. Maybe I just want it to trench. I'll go away and do something else. So automation is really about helping people do their jobs and helping people manage more machines and really using the value of what human and people can do more efficiently and let all the robots do all the mundane stuff. Safety. Safety is another big driver. There's lots of places where people have had to use remote control. They're looking at autonomy because certain areas, maybe it's a dam. If the machine goes off the edge or maybe you get a bit of a collapse, I'm not going to paint the picture, but you all know what's potentially going to happen, right? So if you can get the person out of the machine, then there's massive advantages there with safety. I mentioned earlier about our journey to autonomy with Trimble and what we're focusing on. We don't want to just add operator assistance. We also want to add safety into our products. Think about all the things that you need to have a machine to do. You need to have it do a task, and you want it to stop when it needs to stop. We can also, on this journey, add those to the products that people use today to keep them safer and also let them do their tasks more efficiently. So, and that all drives efficiency. Less fuel, less material, optimizing how you run a machine. And the other thing about optimizing, within Trimble, we don't want to just automate the machine. We do, but that's not where the real prize is. Not just me, we want to automate the site. How can we most efficiently coordinate and optimize the whole operation from end to end? Not just the execute phase, having data go out, executing tasks, recording what's happening, and then being able to adapt and adjust. And not only just for autonomy, but how can we help you today do your jobs more efficiently and understand what you're doing, and are you on track? And are we going to be able to give you the tools and the information now, before it happens, to stop it happening? So all this thing with the journey is how do we actually get there, and what value can we add along the way? So optimizing and automating the site is what we really want to be able to do. Not just a purpose-built machine system. It's like those machines and those multiple machines that are coordinating and they're doing stuff. So we need to be able to automate workflows and work groups of machines. Labor shortages, that's an easy one, right? I just talked about the skilled labor shortage and the construction dilemma. And we want to be able to, again, leverage the ability for one person to run multiple machines. So really, when you bring it down to the basics, you can think of it as in 3 steps, where you've got automation, where you've still got a person in the machine. And then you can start adding safety in it, and maybe the person can get off the machine, but they're sort of still looking after it, to a point then when the machine can execute tasks fully by themselves, and you don't have to worry about it. So I don't know if it's blurry for me, but I might be too close. But it says automation with a safety operator, then automation with a safety remote operator, to then complete automation. And that sort of leads me into the next slides of, when you're looking at autonomy, it's really just automation at different levels. And we've been on this journey for a long time. Think about grade control, where we started back in the late 60s, early 70s with graders. It's progressed to multiple different sensors and 3D and all sorts of stuff, right? It's been progressing. Now we're adding intelligence to help you do the job, not just automating the blade to grade, but where do we need to push the material? If I can steer a dozer to a line or a compactor to a line, what if I make that line very intelligent and smart? And if that line can adapt and change as other things happen? That's where the real value is in, not just for autonomy, but it's how we get there. So when we look at the different levels of autonomy, level 1 is basically the operator is still full, complete control. Level 1 is still grade control, but I need to make the decision of what I want to do. The grade control system can give me indication and guidance, but the person is in full control. So your standard 3D machine control is level 1. Then you start adding more automation to it. So we add automatics to that grade control system. Maybe we can steer things, but you're still in full control. Add some more automation. So you can start seeing the blue, which is the person, is doing less. Now within Trimble, mainly we're in the level 1 to 2 plus, where we add assistance with steering. We can automate the blade. We can steer it. But you still need a person in there, and the person is still control. They're still going to stop. Add some safety to it now. So the operator is still needed. They're still the final backup, but now you can start adding alerts and warn people that something's going to happen, to a point where the person's there and they're really just on the way for a ride. The system's going to stop when it needs to stop, but maybe that system can't do all the tasks and only a few things. Where level 5 is where it just does it, whatever it needs to do by itself for a lot of tasks. That's going to take a long time, just like the other presenter said. But how we get there and the value that we can do along the way is where it really comes into play. So what do we need for autonomous construction? Within Trimble, all of our autonomous solutions and assistant stuff that we're working on is all built around our fundamental core grade control system, which is Trimble Earthworks. It knows where it is, and then we can add to it with operator assistance. We've actually got an autonomous compactor here at the show, which is going to be our lead machine. And one of the reasons that a compactor is our lead machine is very containable and controlled. It doesn't actually move the material, it just runs over it. But think about all the things that you need to create an autonomous compactor. There's a lot of building blocks that can be then scaled out and leveraged with other machines. So machine control and automatics is a key enabler of what we feel that we need for an autonomous machine. Augmented reality and remote control. Augmented reality really helps with not only helping the person understand what they need to build and see, but there's also, when you look at augmented reality and cameras, you can start using those cameras for other things, with understanding the environment and being able to make decisions about what may be there. If you running up to a lamp pole, for example, versus a person, if you've got a really basic thing that just looks if something's there, you're going to do a different thing if you can understand what it is. If it's a person, you're going to stop. If it's a pole, maybe I can go right up or close to it and compact around it. So remote control, what that enables is the ability to basically automate all the movements of the machine. The person's still in control, and it could be tele-remote, or it could be remote control where you've got line of sight. But the key thing with that is the ability to actually instruct the machine. I better speed up, I've only got 7 minutes. 3D design. 3D design is good because you need to actually have a model that you're working to. And a robot needs to know what to do. So if there's a surface that you want to end up at, then you need to have that information there. But equally important is actually having the ability to understand the environment. Because if you set up a task for a machine or a robot, if it starts the task and then things change, if you don't adjust the task, then you're potentially going to be doing the wrong thing. So you need a mechanism so you can understand in real time what's happening on the site. And it could be from other surveyors, grade checkers, it could be from other machines, it could be from drones, it could be on a whole bunch of smarts that are on a machine to actually survey around it, not just where the machine has been. So that ability to understand the world and having like a digital twin of the site that's in real time is key, because you always want to make sure you're doing the right thing, just like an operator would, an expert operator. Work orders and task planning. That's also, so you need to be able to turn that verbal gesture of, hey, going out and cut that pad. You can't just go, hey, go and construct that pad to a robot. Maybe you can in the future, but not now. So how do you actually package all that instruction? Maybe it's compaction parameters or grade tolerances. You need to actually have a task, and you need the ability to send it to the machine. Then you need the ability to actually monitor what's happening. And with that, Trimble, like we've been talking about digitizing and transforming the world and joining the physical and the digital worlds for a long time, but now the real push is turning into information and data, understanding what's happening and being able to have the analytics to actually be able to adapt and be able to change things as needed. On the machine side, if you're not familiar with machine control, basically think about a machine control system of it needs to know where it is, and you need to be able to understand if something's moving on the machine and that thing's going to actually interact with the ground, then you need the ability to actually measure it. And it could be with something looking at it, or it could be a physical sensor on the thing that moves. If you just break it down to the simple things. Then you need the ability to have an interaction with a person or an operator, so you need a user display. And then you need the connectivity element, so you can send tasks and you can actually get that data off the machine to understand what happened. Then you need the ability to make something move. And it could be with hydraulics, or it could be talking to the EH system on the machine. Then if you're running autonomy or you want some safety aspects, you need things in there like what a person would do. Like a person's got eyes, so they need to look around and see. So you need to be able to let the machine do that. So you need sensors on there to actually understand what's around the machine. And in some cases, it's pretty obvious, right? But if you've got sensors on a machine where you can't see, it can see for you. So the ability to detect what's around you, and then there's tools to actually help the operator do their task. There's an example here where we've got augmented reality on the excavator where you can see the design on the machine and you can also see the environment. And that's really good for people to understand what they're going to build versus just a 2D plan or a 3D view. You can actually see how that is in relation to the real site. And it's good if you just to visualize and understand what's happening. Then you can take it a step further. Potentially you can see through the ground of where the utilities might be. Or if you're looking at the machine display, you can get a sense of what's around the machine. Think of an excavator. You see it all the time. It's not safe, but a man in a trench or a person in the trench, and you've got the person and the operator looking over, trying to see what's happening. Most of the time, they're not putting the hydraulic lockout on. They're leaning over. What happens if you knock the levers? You can hurt somebody. But if you've got the ability to see in the trench without actually putting yourself in a safety violation, then it's safer. Ideally, you don't have anyone in the trench altogether, but that doesn't always happen, right? 3D design and actual condition surveying. So I won't spend too much time. I've only got 2 minutes and I don't want to get kicked off the stage. But the key point here is that you need to have designs and stuff that you want to build. You need to be able to have the tools to monitor and record what's happening. And you need to do it now. And you need to be able to make those decisions without waiting next week to find out that you're behind schedule. And with that, you need tools to help you, like scanners, various software elements, and the tools to help you run the job. And all that stuff is needed for autonomy when there's potentially no one doing the task. But we can provide that value along the way. And it starts, again, just adding more to the machine control. So in here, you can see the design. You can see, in this example, there's been a scan, and that's been uploaded into Trimble Works OS. The machine control systems can pull all that information down and provide you a real-time cut fill map of the site in relation to the design that you're building. So you can see where the high spots are and the low spots are, and that can sort of help you do your task. And then as other machines and other surveyors actually survey and update the site, then that map on your display, in your machine, is going to be updating with it. And you don't have to wait for the stand-up the next Monday of the big cut fill board for the site. You can see it on your machine as it happens. Here's a quick video. I'll try and start it.
Trimble is proud to partner with you on the journey toward a fully autonomous
Can they hear it?
future. Taking the initial step to automate time-consuming and repetitive tasks boosts productivity, frees up resources, and gives you the competitive advantage. Horizontal steering control, available with Trimble Earthworks, helps you work smarter and faster. Machines equipped with horizontal steering control follow GPS-designated alignment to automatically travel without operator assistance. This means an operator can concentrate on blade height and grade for greater efficiency. Horizontal steering control creates more consistent lines, regardless of the operator's skill level. This reduces overlap in the total number of passes. It saves time and fuel, and delivers the highest quality spreading and compacting. Horizontal steering control is a vetted solution that's easy to combine with your existing fleet and workforce. In fact, it can decrease operator fatigue and error. Adopting Trimble's proven steering technology puts your business on the forefront of innovation and opens the way toward even greater autonomy. Wherever you are on the journey, Trimble is committed to delivering autonomy on your terms. The future of construction is happening now.
So yeah, those are some examples of the value that we're adding now on our journey to autonomy. I'm just conscious of the time now. I mentioned before, we want to be able to optimize the site. With that, you need to be able to have a mechanism where you can collect all that information and add some intelligence to then update what's happening in site as needed. I've talked to most of this, but it's about working out what do you actually want to automate and what you need help with, and be ability to understand how machines work together and not just focusing on machines as standalone items. You need safety for the operators. There's lots of stuff out there today to restrict movement of people, electronic walls, etc. And you need the tools to be able to run the site, not only for autonomy, but how you get there. Sorry, I'm blowing through this, but I'm over. There's all sorts of aspects needed with safety and operator assistance, the mechanism to collect data, send tasks, the intelligence to know what's happening and what's going to happen before it happens. If you're interested to know more, come and see us at Trimble. We've got an off-site here where you can get in a machine, you can run it, you can see the autonomous compactor. At our booth, there's a sign-up schedule, and you can go every half hour. We've got a shuttle. We'll take you out to a site, and then you can spend some time and then come back. We're at Hall A2, stand 437 if you need any more. So hope you guys enjoyed it. Thanks very much for the opportunity to be here, and I hope someone got something out of this. So cheers. And if you're going to be in Vegas in 2 weeks, we've got our big Trimble Dimensions. So thank you.